So, you're thinking about building your own local AI agent. That's a huge move, but let's be real, the hardware choices can feel totally overwhelming. Well, today we're going to cut through all that noise. This is your definitive playbook on what you need, why you need it, and how to get every last drop of performance out of your machine. Let's dive in.
So, you've got this goal. Run a seriously powerful AI agent right there on your own machine. No cloud, no subscriptions. And that's awesome. But here's the thing you've got to know right up front. The hardware this takes is on a whole other planet compared to just running a simple chatbot.
And yeah, this is really the core of it all. A chatbot, it gives you an answer, and then it waits. An agent, on the other hand, is alive. It's in this constant loop of thinking, doing something, checking its memory, and then correcting itself. This isn't just a quick burst of work, it's a marathon, a constant hum of activity that puts a serious, sustained load on your system. And that's what we need to build for.
Okay, so this right here, this is our playbook. This is the roadmap for the next few minutes. We're going to break down every single piece of this, starting with why agents are so hungry for power. Then we'll get into the nitty-gritty of the components, and we'll finish up with the pro-level optimizations that'll absolutely supercharge your setup.
All right, first things first. Why? Why are these agents so darn power hungry? What is actually happening under the hood that means you need such a beefy machine to keep up?
It all boils down to what we call the agent loop. See, unlike that one-and-done chatbot, an agent is constantly cycling. It's reasoning through a problem. Then it's using a tool to take an action. Then it's pulling context from its memory. And then it's looking at the result and correcting its own plan. It's not a sprint, it's a marathon that just keeps going.
Okay, let's break this down, because this is where the rubber meets the road on hardware. First, you've got this thing called the KV cache. Just think of it as the agent's short-term memory, and it lives inside your GPU's VRAM. The longer the agent works, the bigger that cache gets. If it fills up your VRAM, the agent basically has to start forgetting stuff to make room, which slows everything to a crawl. Then, for every single step it takes, it has to reread its entire history. That eats up memory bandwidth like you wouldn't believe. And if you want to get fancy and run multiple agents at once, you better believe your VRAM needs are going to skyrocket.
Okay, so now that we know why it's so demanding, let's talk about the what. What hardware do you actually need to buy? Let's decode the essential parts of a machine that's truly ready for AI agents.
All right, let me be absolutely 100% clear on this one. When we're talking about local AI agents, the GPU's the star of the show. And on that GPU, one thing matters more than anything else. It's video RAM or VRAM. VRAM is king. Full stop. There is no getting around it. It determines how big of a model you can run and how long of a conversation you can have before things fall apart.
And this table lays it all out nice and simple. It shows you exactly how much VRAM you need based on your ambition. If you're just a hobbyist messing around with a small 7B model, yeah, you can get by with 8 gigs. But if you want to build a serious agent, you've really got to be in that 16 to 24 gigabyte range. If you try to do serious work with less, you're just going to have a bad time. Seriously.
Okay, next up, let's talk about your system RAM. And there's a super simple rule of thumb here. You want at least double the RAM of your GPU's VRAM. Think of it as your safety net, your overflow parking lot. It's there to catch bits of the model if your VRAM gets totally maxed out, and it's absolutely essential for holding all the documents your agent needs to search through for RAG.
Now, what about the CPU and your storage? These are your supporting actors, but they have crucial roles. The CPU isn't actually running the AI model. It's more like the orchestra conductor, telling the agent what to do and managing all its tools. That's why fast single-core speed is so important. And for storage, it's NVMe or bust. The speed of a modern NVMe drive makes a massive difference in how fast you can load those giant models into memory to get started.
All right, theory's done. Let's get down to brass tacks. It's time to take everything we've learned and turn it into some actual hardware builds you can go out and buy. Let's pick your rig. So we're back to our playbook here, and this time we're zoning in on these 3 specific builds. This is where you can figure out what makes sense for you, for your goals, and for your budget. We've got something for everyone, from your very first experiment all the way to a full-blown professional setup. First up, we've got the minimal agent box. An RTX 3060 with its 12 gigs of VRAM paired with 32 gigs of system RAM, this is your perfect entry point. It's not going to be the fastest thing on the planet, but it's more than enough to get you in the game. You'll learn the ropes, build some cool personal assistants, and really get a feel for how these agents tick.
Okay, now this is what we're talking about.
This is the sweet spot, the one we really recommend for most people doing serious work, the professional rig. Making that jump to a 24GB card like a 3090 or a 4090 is an absolute game changer. This is where your agents become fast, responsive, and capable of handling really complex tasks, even running multiple agents at once. This is the rig for real development.
And then there's the top tier, the enterprise, or research rig. Now we're talking about professional workstation cards with 48GB of VRAM or even more. This is what you need when you're playing with the big dogs, the giant 70 billion parameter models. This hardware unlocks the highest quality reasoning and lets you process just a massive amount of information all at once.
But hey, there's a really interesting wild card in all of this: Apple Silicon. Because the CPU and the GPU share one giant pool of memory, a Mac Studio with 128 gigs of unified memory can do something pretty much no consumer PC can. It can run one of those massive 70B models entirely in its memory. It's a totally different way of thinking about it, but man, for running those huge models, it's a beast.
Okay, so you've got the rig. You're set, right? Well, not quite. The hardware is just half the battle. Now we get to the fun part, opening up the optimization playbook and learning how to squeeze every last bit of performance out of that machine.
The number one absolute biggest bang for your buck optimization is quantization. All this means is shrinking the model down, kind of like compressing a giant file. And for agents, these 4 and 5-bit options are the sweet spot. You get a massive speed boost and use way less VRAM, all for a tiny drop in quality that you'll probably never even notice.
But we can go deeper. We can tune the actual software stack. You can enable a feature called flash attention, which can literally cut the memory needed for long conversations in half. Using modern runtimes like Llama.cpp or VLLM isn't optional. It's a must for good performance. And a real pro move, you can even quantize that KV cache we talked about earlier, letting you handle enormous context windows without crashing your GPU.
Believe it or not, even your choice of operating system makes a difference, a real difference. Just look at this. Linux consistently gives you a 10 to 20% performance boost over Windows for this kind of work. Why? It all comes down to better GPU memory management and less overhead. It's basically a free performance upgrade if you're willing to make the switch.
So, after all that talk about hardware, software, profiles, and tuning, what's the one thing you absolutely have to remember? It all comes down to this one single golden rule for building local agents that are actually useful.
It's this, right here. This is the golden rule. Latency beats raw intelligence. In the real world, how fast your agent responds is everything. An agent that comes back with an answer instantly, even if it's a little less smart, is 1,000 times more useful than some giant genius model that makes you wait 10 seconds for every reply. A fast 13B agent will beat a slow 70B agent every single time.
And there you have it. That's the playbook. From the core components to the pro-level software tweaks, you now have the complete blueprint. We've given you the map. So the only question left is, what are you going to build?